Okay, so my first point is 33,166. So yours is probably going to be better than mine because I'm having to wing it here without any grid lines. But since we're going by fives, you're kind of guessing too. So just do your best. $28, 152. Plotting those as ordered pairs. This is the X, and this is the Y. X and Y ordered pairs. So this would be 33,166. And then this one would be 27, 145. Finding all of those points. Okay. Is 3 or 155? 33, 166. Oh, I think 30. Oh, that's 32. Okay, and 27, 123. All right, that's my scatter plot. So now we have some draw a line of fit. So here are some steps for writing an equation for a line of fit. The blue shows the requirement for your line. You must have the same number of points above and below the line. Approximately. If it's like 4 and 3 or 6 and 5, that's okay. But you can't have like 8 points above it and no points below it. That's a wrong line. And you must move through the data. So I'm going to draw a line of fit by hand on my scatter plot. First, I'll show you some wrong lines, and then I'll try to get a good one. You guys will use your ID or a ruler to make a nice straight line. You'll probably have to erase it and try more than once. I normally do. This is a wrong line. Let's look at some wrong ways. Okay, do not connect the dots. We are not connecting dots here. That's wrong. Okay? Don't go through the middle and not go through the data. That's wrong. You need to be generally through the data. Wrong. This one's technically wrong too. What's wrong with this one? It's actually pretty good, to be honest with you. But there appears to be 1, 2, 3, 4, 5 points above it, and only 1, 2, 3 below it. So it could be a little bit better. Okay? That one's actually pretty good. I meant to do more wrong. Something like this. Like that's very wrong because almost all the data is above it and there's nothing below it. Okay? You want to try to get in the center. So now I'm going to try to do a good one. I don't always get it on the first try. So I erase it and I go again. And again, you guys are on graph paper, so yours might be even better than mine. It's not too straight. I wish I used my meter stick here, but I keep messing up when I'm using it. So. See if I can get any better here. Are they allowed to be on the line? Yes. You can have some dots on the line. That's okay. And the more tightly correlated the variables are, the more likely you are to have lots of points on your line. If it's no correlation and it's scattered all over, then you're probably not going to hit too many. But if it's very correlated, you might hit quite a few. Now I happen to go through 2 points, and I hit 1. I have like 3 above and 3 below, and I'm kind of through 2. So that's your first step, drawing a good line of fit. Next, we need an equation for this line. So once I get my line done, I'm kind of ignoring the red data. Focusing on the line. I want an equation on the black line. So what I'm going to do is I'm going to pick 2 points on the line, and I'm going to find the slope of the line I just drew. It doesn't have to be 2 points you went through. Find any 2 points that you think look kind of easy or very clear. So I'm going to, on purpose, pick 2 points that didn't exist before. Like when I look up from 128, it's at about 150. Or sorry, 28. So I'm going to use the ordered pair 28, 150. Your line might not go through that point. Your line might go through a different point. That's okay. I'm going to do also I'm going to do 23 and 135. So you find any 2 points on your line. If you want to use my points on this first example, you can. If you want to move forward with my data, you can. So I'm going to do slope formula based on the 2 points that I picked. Okay, so what step am I on right now? I'm on step 3, slope formula. So I'm going to do 23, 135 is my first point. And 28, 150 as my second point. So, oh man, this worked out really good. I got an even number. You might not. You might have a decimal or a fraction. I did this last class by hand, and I had, instead of an even 3, I ended up with 5 over 2, which was 2.5. Did anybody do points different from me? So cool, you guys. Anybody willing to share their slope? Yeah? What about you? What was your slope? Yeah, do that. Anybody do their slope from their 2 points? Not yet? Okay, I'll give you more time. Sorry. So the 2 points, I did give me a slope for your slope could be quite different based on how you drew your graph. Yeah? My slope was 5. 5. We had that slope last class too. Anybody else willing to share theirs? 3? What'd you get? 3 over 2. 1.5. 3. Lots of 3s. Okay. So that's step 3. Check. Find your slope. Step 4 is to actually write the equation. We want an equation that looks like y equals mx plus b. So I'm going to use the slope in the first point, and I'm going to do point slope form to write a linear equation. So I already have x1, y1. I'm going to plug that in. And I already have the slope. I just found it. And I'm going to find myself an equation for my line. Plug in your x, your y, your m, and then we're going to use the distributive property. And we're going to rearrange this guy so it looks like y equals mx plus b. Distribute. Get your calculator ready. Use your calculator. Is this 66? Mm-hmm. Is it? The answer? Or the b value? Yeah, that's 66. 66. Thank you. This is an equation for my line. Your line that you drew by hand is probably different if you use drawn points. Okay, so when I grade this, I would expect different, not this time, the first one, but in the future, I would expect people picking different points and getting a little bit different slopes and getting different y-intercepts. It's all just kind of random when you do it by hand. When you move up into statistics and research and things, this process becomes much more precise and everyone's data gets closer and closer. But for now, this is how we're doing it. I wish I could see my y-intercept. I calculated it to be 66, but I used a break here, so I don't really know where my line's hitting. I mean, if I kept going, this could be 125, 120, 115, but then there's also a break here, so I can't see a y-intercept if I'm utilizing a break in my data. So I'm hoping 66 will work out. Now, we're going to do this exact same data using technology and see how close we got by hand. So if you have the TI-36 calculator, grab it, the first button. If you don't, go to desmos.com. I'm going to show you how to do it on there. So with the TI-36 calculator, you hit the data button to start. And you guys help each other. So here's data right here. This button's going to do a lot of work. When you hit data, you should see L1 and L2. The X values go in L1 and the Y values go in L2. So we're going to do this exact same data. So I would hit 33 and then enter, and your cursor will go down. 25 and then enter, and you fill in all the X's and then you fill in all the Y's. Let's go to desmos.com. Just like that, it's got Desmos, you hit the plus sign. Find Trying to make this better. Plus sign, table, and you have to fill all the data in the table. Yep. How are you going to do the promo? You leave right now. I mean, you can go right ahead. This is your chance. I'm not doing this again. Okay. Are you using a calculator or Desmos? Are you using a calculator or Desmos? Okay, have you figured out how to enter a table in a Desmos? Yeah. Yep, go ahead and do it. Yep, you gotta fill in the exact table. Alright, there's the table. Calculator people. After you get all your stuff in, you're going to hit second data. And then it's going to do the calculation for you. You're going to use the oval arrow button to scroll down to number 4, which says lin reg. This is called linear regression. Yeah. Thank you for asking. You guys ask me questions, okay? I'm just gonna keep rolling. You guys stop and ask me. Okay. Next to linreg, what does it say? It does. It says ax plus b. And so in this calculator, instead of calling slope m, they call it a. You're gonna hit enter. Later in the year, we'll do quadratic regression. And then you're going to boom, boom, all the way down. So you're over the word calc. And you hit enter. And then it's going to tell you what A is and what X is. And so you guys are getting a feel what data entry feels like. Data entry is kind of important. Lots of fields in schools and in the medical field. People just entering data all day long. Checking your work and checking your work again. 33, 25, 22, 30, 28, 32. 26, enter. Data. calculator, people, you should have found your A value to be 3.05, and you should have found your B value to be 63.53. You entered the data right. And that's going to write your equation. So that means your equation is y equals 3.05x plus 63.53. That's the exact line of fit for our scatter plot. Desmos, people, you're going to come down to this line. New line. And you're going to type this in. Y1. Squiggle. 1 squiggle. And x1. That's a 1. Maybe I'll do a little. 1. x1 plus b. And it's going to come up with the exact same numbers, which is very cool. Y. Where is the squiggle? I just have it. Y1 squiggle m x1 plus sign b. And then here's all the data according to Desmos. We got our M is the same, 3.05, and our B is the same. So it doesn't matter if you do it on the TI-36 calculator or on Desmos, you get the same slope and the same line of fit. And so here is an exact line of fit. So let's compare to what I did by hand to what we had here. Mine came out pretty good, I think. Sometimes I don't get this close. By hand, I had y equals 3x plus what? What I got? 66? Yeah. 66. And using technology, we get y equals 3.05x plus 63.5. Pretty close. Sometimes I am way off. My slope will be much higher, my intercept will be much lower, and things like that. In algebra 2, you need to do both. You need to prove that you can do it by hand, and you need to prove that you're starting to learn how to use technology for your math and your science. Who's got a question? I'm sure there's between 5 and 10 of you who weren't successful in the calculator or weren't successful in Desmos. I would like to answer some questions. So before I walk around and answer questions, we haven't completely finished the work yet. When I come to the question, I'm wondering, did I even answer it, right? It says, write an equation of a line of fit. And then it says below it, use technology to do a line of best fit. Best fit is the technology one. You guys see the difference in the wording? We got a line of fit, we got a line of best fit. Now we have to estimate the height of a female whose humerus is 40 centimeters long. This is a frequent theme through this curriculum. You have to write an equation, and then you have to use that equation. So I'm going to plug in 40. 3 times 40 plus 66. I'm going to plug in 40 to both of them. 66.5, is that right? No, it's 63.5. I guess that's going to be exactly. So I'm using my calculator. Well, this would be 120 plus 66 is 186. And this would be 183.5. So typically there is a correlation coefficient, or there's a plus or minus range that the data scientists will rely on. So if we were to find a humerus bone and they were trying to figure out the height of the female they belong to, they would say approximately someone who's 186 centimeters plus or minus 1 or plus or minus 2. And then they would look into their data and try to figure out, if there's a missing persons or whatever. Or again, going back to dinosaurs or any type of study where a skeleton comes into play, they'll look at that line of fit to make predictions and analyze them. Okay? Let's answer our complete sentence. It says compare this to your estimate in part A. So. Line of fit was 9. So the line of fit shows that a humerus of, actually I think we're in the last 10 minutes now. A humerus of 40 centimeters results in a height of 186, while the line of best fit shows 183.5. And that's the lesson today, being able to do it by hand, being able to do it with technology, and then be able to make comparisons about it. You got it. You have 1 minute. We have 11 minutes left in class. Let's take a look at what the assignment looks like. Did you guys have a chance to write the assignment down from the hours? Let me throw it up there again. No, I'll wait here for a minute. You're not the only one that needs that answer. Now ask me a question about your technology. Oh, you got it. You did a good job. You didn't do it. Do you understand the table? It looks a lot like volume design. This end value is the slope. So the slope of this line is exactly the same. We didn't have to use the formula to do the calculation for it. And the y-intercept is 66. We didn't have to do any math for it. Oh, we take this in. And then, yeah, if you go to the table first, this will give the value from the table below. Cool, right?
This one, I don't know what it
It says estimate the height of a female humerus display.
So, for the 3? For the 3. I thought it things you guys are doing.
So I did it in this one. Or did I mess up?
Because I thought, because this one, I thought, this one is this. No, I know you put it for it.
I should have plugged in for you both of them. Oh, so I missed 0.05. Thank you. How much does it change the number? Oh, yeah, because I was trying to do it in my head. You guys, this was off a little bit. This is 3.05, and this final answer is 185.5. It's even closer than I thought. It's only 0.5 centimeters away. That's great. Thank you. All right, I'm coming around. Ask a question. It can just be like, I have no idea what we did. Yeah. And L1 and L2. You guys need to get really good with these calculators, but you have to ask. You can't give up. Okay. You can't just say, man, I get it. Okay. Which problems are we doing? We're doing 15 to 18. So look, you guys, all of them say use technology. Use technology. Use technology. None of these I assign you on your own or to do it by hand. I don't know if you appreciate that or not. It's page 47 and 48. It's 15 to 18. Alright, coming around. Ask a question about decimals. Ask a question about calculators. No. No. It's for doing it by hand and for kind of just sketching it. It's not going to come out exactly the same. It would be wrong, let's say, if the calculator has a positive slope. If I did it by hand, I got a negative slope, I would think I made a mistake. So it should be somewhere in the same number. Like, so if this slope was 3 and I calculated the slope to be like 100, I probably made a mistake. But you can give or take several numbers. Yes, on a touch screen, it's beautiful, but here you have to enter that plus and minus sign. Yeah. You gotta keep like, grab it. You shut up. So I bought on the line, so maybe 21 to 30. No, you do want it on the line. It doesn't have to be a point that you've already drawn. You can draw a new point. And then you can start formula. Modeling with linear functions, and this is trend line. Line is it. Line is it. Questions over here? Questions over here? Yeah, you look now. So regression, the technology that the regression does, it's actually finding the average distance from every point to the center. It's like finding the kind of like midpoints. And so this line has calculated all the distances from the scatter plot points to the center and drawn itself perfectly at an average. Okay, so what it means is that generally, if scientists will start to draw like interesting conclusions from that, but generally the ones above the line have a more of a distance, and the line had to compensate for that and come closer. We learned a lot about it in statistics. Yeah, those are good. Those are good. Okay, I am available after school today if this